Yeah. Hi everyone. In the previous class we completed up to the 38th question. Now we'll start 39th question. 39th question, find the set of the factors of the 256. See 39th question, find the set of factors of 256. 256. Okay, is there any logic? Suppose if you write the factors of the 256, shall I write until the 256? Otherwise, any logic is there. Means as like 1 into 256, 256, 2 into 2, see as like. So 1 into 256 equals to 256, 2 into 2, 2 2 is 4, 2 8 is 128 is 256. So as like, shall I write up to 256? Or any logic is there? Yeah, there the logic is there. If they given any number, okay, if you know the square root, okay, then it is very easy. See, square root means 256. Square root is 16. Means up to 16 if you write is enough. Okay, I'll follow the logic. See here the factors. And here they said set. Set means every element, means every factor it will come only one time. We no need to write the two, but sometimes it may come. See here the 1 it will come here also. In a 256 ones also it will come. See here the 256 into 1s 256. Both times it will come. But we should write only one time because they asked the set. Okay, everybody must and should remember. Okay, now I am going to write. Here, see factors of 256. So I am writing in a set. See 1. Here it is a 1, and this side writing the 256. Here the next 2. For the 2, 128. 2 128 is 256. Next 3 table. 3 table, is it possible? 3 8 is 24, 1 remains 16, not possible. 4 table, 4 6 is 24, 1 remains 16. So 4 is possible. See 4. So 4 6 is 24, 1 remains. 4 4 is 16. So next one is 5 table. 5 table, already I given the divisibility rules. 5 table unit digit is 0 out of 5, so not suitable. Next 6 table. 6 4 is 24, 1 remains 16, but 16 it won't go with the 6 table. So next one is 7 table. Is it possible? So 7 4 is 20, so 7 4 is 28. No. 7 3 is 21. So 21 means 4. 4 6 is means it won't go. So next 8 table. 8 table it will go. See 8 3 is 24. Okay, 1 remains. 8 2 means 8 3 is 24 and 8 2 okay. Next 9 table. With the 9 table, is it possible? See 9 2 18. So 76, not possible. So next 10 table, not possible. 11 table, not possible. 12 table, 12 2 is 24, 1 remains 16, it won't go. 13 table, no. 14 table, 14 2 is 28. If you take 14 ones also, it's not possible. Next 16 table, 16 16s. So but I have to write only 116 because here they ask for set. When we will say the set is a collection of the element. Only one time we will means any element we will take in the set only one time. We no need to take the 2 times. See here already I said 1 will come the 2 times, but we have to take only 1 time. So this is the answer. So factors of the 256 are the 1, 2, 4, 8, 16, 32, 64, 128, 256. Is there any doubt? Okay, take down the problem. 6 and 936 using the factor method. Okay. So here 40 question. factor method. Okay, by seeing the question itself, we'll get one idea. Are you able to guess? Once observe, is there any relation between that 156 and 936? So I can guess it. See, I know the logic of means already I told in the previous lesson. So means the previous video. So what is the unit digit? For the unit digit, I given one chart also. Here, unit digit is 6, and here is also 6. When if with one table, when we are multiplying, when we will get the 6, once we will check. See, in the with the 6, see 6 we will get last digit is 6. We will get this number or not once we will check it. See, 156 into 6. 6 6 36 upside 3. 6 5 30 plus 3 33 upside 3. 6 1 6. Yeah. So hint is given in the question itself. Suppose they asked the GCD and one number is a factor of the another number. The factor is means that number, the given number is the answer. We no need to find out anything because see here I use the logic. Because 156 I can write as like 1 into 156, and 936 also I can write as like 6 into 156. See, common 156 is a common, so then I can write the GCD is 156. That's it. You no need to write the factors of this 156. Afterwards, factors of the 936. From that, which is the common factors. From that, which is the greatest common factor. That if you write, it will take more than 2 to 3 minutes. But if you use the logic, then you can complete it only in 1 minute. Got an idea? Is there any doubt? Next 41 question. Find the LCM of the 1296 and the 1728 using the synthesis method. Okay. So can I take directly? Otherwise, can I write the question? Okay, can I take directly? Okay. See, synthesis method means see this method. So here they asked the numbers that are 1296, 1728. So what we want to do here for the finding the LCM, which is the best technique? The best technique is first you want to take with the prime numbers and go on. So starting from prime numbers, starting from the 2 onwards, 2, 3, 5 as like if we go, then it will come very easily. Okay, so I will go the same method. So 2 table here, 2, 2, 6 is 12, and 2, 4 is 8, 2, 8 is 16, and 2, 8 is 16, 1 remains, 2, 6 is 12, 2, 4 is. See here, next one, 2, 3 is 6, 2, 2 is 4, 2, 4 is. Next one is 2, 4 is 2, 3 is 2, 2 is. Next one is 2, 1 is 2, 2, 6 is 12, 2, 2 is 2, 2 is 2, 1 is 2, 6 is. So next one also same, 2, 8 is 16, 2, 1 is. Next 2, 1 is, see here the 1, it won't go. So then we have to keep the 0 because they are taking the next 2 digits. So that is 1 and 6. So 16, 2 8 is 16. So next number is 2 table. See 2 table, with a 2 table 81 is not possible. Okay, this one is possible. But we will go for the next number which is suitable for that. So 3 table. With the 3 table it will go sharp because it's the multiple of the 3. And here 3, it will also go. So now I am taking 3 table. So 3 2s 6, 2 remains, 3 7s. So 3 3s 9, 1 remains, 3 6 18. Once again it will go with the 3 table, 3 9s, 3 12s. Once again it will go 3 threes, 3 fours. So next, see, these two numbers are the co-prime numbers. When the co-prime numbers came, that time you can stop. Some people they may do isolate also. Suppose if you do with the isolate also same, 3 ones, 4 remains. Once again with the 2 table, 2 twos. If you do isolate also, you will get the same answer. When you get the co-prime numbers, means if you know the definition of the co-prime numbers and if you are able to apply, then you can stop there. So now I need the LCM. See, LCM. So that is 1, 2, 3, 4, 5, 6 twos. 1, 2, 3, 4, 5, 6. Threes. 1, 2, 3, 4. So 1, 2, 3, and one more is 4 is I am writing down set. So now here 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32, 32 twos are 64. Okay, this is 64. 3 threes are 9. So 9 threes are 27, 27 threes are 81. If you multiply, then we will get, see here I am doing as well. So answer is 1584. So I don't have the space that side, that's why I done the rough work here. But you should do always the right side only. Okay, that side only you should do. Okay. So is there any doubt? Find the HCF of. So here they given the fractions. So we have to find out the HCF of the, see, 2 by 5, 12 by 5. And one more is 3 by 4. We have to find out the HCF of these numbers. Okay. So here, what technique we can use? HCF, already given the principle in the last video. That is HCF of the fractions means that HCF of the numerators by LCM of the denominators. Okay. HCF of the fractions means, say, so HCF of fractions. So equal to, so HCF of numerators LCM of denominator. Okay. So now, so I am going to find out the HCF of the numerators. So the numerators is here 2, 12, 3 are the numerators, and denominators are 1, 5, 4. For this we have to do LCM. For this we have to find out the GCD. Okay. To find out the GCD, easy technique is done. Suppose you can take in any order, either descending order, otherwise ascending order. Any one order you can take. So I am taking that ascending order. 2, 3. See, 2, 3. This method only you know. So 2 ones are 2, 1 remains. See, this 2 will come here. So 1 2's 2. So HCF is here the 1. So 1 and 12. So 1 12's 12. So here the GCD is our HCF. We can call HCF also GCF. HCF of 2, 12 and 3 is 1. Now we have to go for the LCM. Okay. So here the LCM. See, by the 2 table. So by the rule I am going to do the. So next term 1 so 5 table. But actually by seeing only you can write it. You no need to do that. So I followed the rule. So that's why I wrote that 3 steps. So LCM. So LCM of 5, 5 and 4 is. So that is 2 into 2 into 5. That becomes 20. That becomes 20. So principle is, so HCF of given fractions. So given fractions equals to, see that the HCF of the numerators is 1, denominator is LCM is 20, so 1 by 20, that's all. Okay, I think some may have the doubt. I will do once again. Okay, here they ask the HCF of the three fractions. So for the principle is HCF of the given fractions equals to numerator, HCF of the numerators we have to write upside, and downside LCM of the denominators. LCM of the denominators means for these three numerators we have to find out HCF, and for these three downside we have to find out LCM. Both together, as like if you write, then we will get the HCF of the given fractions. So now I taken 2, 1, 2, 12 and 3. 2, 12, 3 I taken. Here I done the division method. So 2 table I taken, 2 ones are 2, 3 minus 2 1. So this 2 I brought here. See this 2 I brought here. So 1 2s are 2. So 1 is a GCD here. So next one more number is left out here, that is a 12. So I taken the 12. 1 12s are 12. So it's all. So now HCF of these three numbers is 1. Now we go for the LCM. See LCM, some people they may do directly answer first 5 table, afterwards 4 table. That's also correct only. But I am going according to the rule. So I will take only prime numbers. That only I am following. So 2 table. So this it won't go same as it is. This also it won't go as it is. So 2 2s are 4, and once again this won't go. This also won't go. So 2 1s are. Next 5 table 5 1s are 5 1s are. So all here I came the 1. So then LCM of the 5 5 4 is, so 2 into 2 into 5, that become a 20. So now HCF of the given fractions is 1 by 21. See here HCF of the numerators is 1 and LCM of the denominators is 20. So I applied. Now I think got an idea. So you take one number, means I will like similar numbers and you do. Otherwise I will give it on board. Next question is 43rd one. So reduce that 6,902 divided by 6,561 to its lowest term. So I am taking that 43rd question. So question I am writing half only. So that is 6,912 divided by 6,561. So we have to make it that in a lowest form. Lowest form means you know that. So I am taking here. So 6912 and 6561. Okay. So here, if you follow which method, then we will get easy. Anyone have an idea? Suppose everybody will say cutting method. Okay. Once I will show. Okay. Here, so once I check with 3 tables. Suppose 2 table, this one it won't go, this will go. But I'll go for 3 table. So then 3 table up one will go, and downside also will go. So 3 table I am taking. So 3 2s are, 3 3s are, and these 2 digits it won't go. So then when I am taking the 2 digits, you have to keep here the 0, and 3 4s are 12. So as like you want to bet. Next 2 6, 3 2s are 6, 3 1s are 3. So 2 remains 26. So 3 i's are 24. So 2 remains 21. 3 7s are 21. So cut as like. Okay. Next one. So with the 2 table it won't go. So next once again I am going for the 3 table. Once I will check. 3 7s are 21. 2 remains. 3 6 upside 1 will go. 3 7s are 28. So downside on also it will go. Okay. So now 23 here. So 3 7s are 21. 2 remains 20. So 3 6 18. So 2 remains 24. 3 8s are 24. So once again here 3 7s are 21. So 3 2s are, okay. So next 2 remains 27. 3 9s are. Once again with so upside 8 is there and downside 9 is there. So with the 3 table once I will check. So 3 2s are 6, but 1 remains. 3 5s are So 3 18s it will go. So 3 2s are 6. So 1 remains. So it will also go. So 3 2s are 6. 1 remains. 3 5s are 15. 1 remains. 3 6s are. So 3 2s are 3 4s are 12. 3 3s are. So now 256 and 243. So 243 and 256 it won't go with any one table accurately. So answer is 256 by 243. Yeah, my dear children, the next question is that's the 44th question. So here they given the average. The HCF of the two numbers is they given the 12 and the LCM is 144. If the one of its number is 36, find the other number. Okay, given that I will write here 44 question. So they given HCF. HCF is how much they given here? 12. Okay. Next LCM also they given. LCM is how much? 144. One number they given, that is number 1. So number 1 how much it is? 36. 36. What we want to find out? Number 2 we want to find out. Number 2 we want to find out. Already I explained in a previous video, that's principle is that number 1 means the relation between the LCM, HCF and the given numbers. Okay, that number 1 into number 2 equals to HCF into LCM. Okay, but we need here the number 2. So number 2 I needed. So HCF into LCM by this number 1. Because number 1 I know. So HCF is how much? 12. LCM is 144 divided by that 36. See 12 ones are 12 threes are. So 3 ones are 3. 3 ones are 3. Then 3 table. So 3 fours are 12. So 2 remains. 3 eyes are 24. So answer is 48. Number 2 is 48. That's all. So very easy now. If you are able to remember this principle, that's number 1 into number 2 equal to LCM into HCF, then it is easy. As like you can make so many means 3 formulae. Here you can write for number 1 also. You can write for the HCF also. You can write for the LCM also. I given. Okay. Here there's a 45th question. They given has like here, find the greatest possible length of the rope that can be used to measure the two sides of a length, that's 24 meter and 18 meter. Okay. Here in the question itself they given the logic that find the greatest possible length of the rope. Okay. Of the side means they taken the two lengths. By using the one tape we should measure accurately the two. So in greatest possible they given greatest means it's HCF. Greatest means HCF. So here they given that the two numbers that are 24, 18. So if you find out the HCF 18, 24. So 18 ones are 18. So 6 remains. This 18 will come here. So 6 3s are 18. So here GCD or HCF of 24 and 18 is 6. Means by using the 6 meter tape we can measure the two lengths accurately. So that's the logic. Okay. My dear children, once I will recapitulate what we learned in this chapter. Okay. So chapter name is real numbers, LCM and HCF. In that first we started with numbers. So numbers, in that natural numbers, the countable numbers were called natural numbers. It starts from the 1 onwards, 1 to infinite. Okay. Next one is the whole numbers. Whole numbers start from the 0 onwards. Means countable numbers, including the 0, we say the whole numbers. Whole numbers are indicated by the capital W, and natural numbers are indicated by the capital N. So next one is integers. Integers are positive numbers, negative numbers, and 0 included. So we say that are integers. Integers are indicated by the capital Z or I. Next one is the rational numbers. Rational numbers are indicated by the capital Q. Rational number definition is the numbers which are in the form of the P by Q, where the P, Q are integers and Q is not equal to 0, then that numbers are called rational numbers. Next one is irrational numbers, means there's a Q dash. So Q dash, here the numbers which are unable to write in the form of the P by Q, that numbers are called irrational numbers. Okay. So next one is we went for the decimals. In the decimals, so terminating decimals, so non-terminating decimals. In a terminating decimals, that denominator is a multiple of the 2 and 5. Means either 2, otherwise 5, otherwise a combination of the 2 and 5. Then that fractions are the terminating decimals. If you go for the non-terminating decimals, in that once again the two types. One is a recurring decimals, means some digits it will come continuously. So then we say that is say suppose 1 by 3, that is a 0.33333. So then we write that 0.3 bar. So that are called recurring decimals. What we will call recurring decimals. Some decimals it won't terminate and it won't stop. That like numbers also there. Okay. So non-terminating decimals. So next one is in the numbers itself. So we went for the even numbers. So unit digit are 0, 2, 4, 6, 8. That numbers are called even numbers. Odd numbers, in any number, the unit digit is 1, 3, 5, 7, 9. That numbers are called odd numbers. Compositive numbers. So compositive numbers means here the factors it will include. Means if a number have the more than the 2 factors, that numbers are called the compositive numbers. The best example is if you start from the 4 onwards, odd compositive number is a 9. Already I given in my second or first video, I think. Okay. Next one is a prime numbers. So prime means if a number have only 2 factors, means a factor has a 1 and itself. So that numbers are called the prime numbers. If you go for the prime numbers only, twin primes. So difference between the 2 prime numbers is a 2. Then we call that numbers are the twin primes. Relatively prime numbers. Relatively prime numbers means any 2 numbers, no need to be the prime. Okay, any 2 numbers, it have only 1 as a common factor, then that numbers are called relatively prime numbers, or the co-prime numbers also we will say. And there we learn the 2 different method, that is Aristotle's method. It means for finding the prime numbers. So divisibility, division method also there. Okay. So next one is between the 1 to 100 we have the 25 prime numbers, and between the 1 to 50 we have the 15 prime numbers. Okay. So next one is elements. So before going for the elements, properties also there. Properties are closure property, means A operation B equals to C. This A comma B comma C belonging to same set. Suppose if we take the natural numbers, if you take the integers, it's a integer, rational number, whatever also. So then if it's satisfied, then we say there is a closure under that operation. We can there we can substitute where the A operation B, there the plus minus into division. So mostly minus and division will be not satisfied in so many cases, but some cases it will be satisfied. So you must and should identify that. So next one is a commutative property. Commutative means A operation B equals to B operation A. Just we are interchanging the position. If it satisfies, so then that is called a commutative property. Here also you can apply the plus and into these 2. It will be satisfied in some cases, but minus and division it won't satisfy in all the cases. Okay. Next one is associative property. A operation half B operation C equals to A operation B of C. So this is the associative property. Then distributive property. A into B plus C equals to A into B plus A into C. So here we can apply for the minus also. A into B minus C equals to A into B minus A into C. This property is known as a distributive property. So in that one more is elements. So additive identity element. Additive identity means when we are doing addition, we are getting the same, means after doing the addition also, this is one number, this is one number. When we are adding this number, we are getting any another number, same number, this number only we are getting. Suppose 0 plus this number, so we are getting this number only. Yeah, so then we call this 0 as the additive identity element. If we come for the multiplication, so in a multiplication, 1 is a multiplicative identity element, means any number into 1 it leaves the same number. Result is that number, means what we are multiplying, that number only we will get. So that's why 1 is a multiplicative identity element. Next, finding the factors. So for the finding the factors, we use the different technique. I wrote all the 3 methods what you learned from the 3rd class to here. So already I given in the video. So but in this IIT, by seeing the number itself, by using one logic, you must ensure recognize how many factors it will come for that number. That also I given in this. Next one is LCM, so least common multiple, HCF, so highest common factor. Otherwise we say that one is the GCD also, greatest common divisor. So relation between this LCM and HCF also I given, that is number 1 into number 2 equal to LCM into GCD. And the divisibility rules. Divisible rule by 2, that's a unit digit. So by seeing the unit digit only, we can say that that number is divisible by the 2 or not. So for that technique is 2, 0, 2, 4, 6, 8 is there, then it is divisible by 2. If we go for the 3, sum of the digits means in the given number, if you add all the digits, then it is divisible by the 3. The whole number is divisible by the 3. If you go for the divisible by 4, so last 2 digits means unit digit and 10th digit is divisible by the 4, then the whole number is divisible by the 4. And 5, divisible by 5 rule is last digits means unit digit are the 0 and 5, so then that number is divisible by the 5. 6, divisible by 6 rule is if a number is divisible by 2 and 3 both, so then it is divisible by 6. 7, it is a little bit lengthy process, definition is not accurate. So 8, last 3 digits means unit digit, 10th digit, 100 digit. The number formed by this 3 digit is divisible by 8, then the whole number is divisible by the 8. 9 as usual as like a 3, so sum of the digits is divisible by the 9, then the whole number is divisible by the 9. So 10, already everybody you know, unit digit is 0, then it is divisible, otherwise no. And the 11 divisibility rule is alternate digits sum is either the 0, otherwise the multiple of the 11. So then that number is divisible by the 11. And for the finding the HCF of the fraction, suppose HCF of the fractions is HCF of the numerator by LCM of the denominator. Suppose LCM of the fractions we needed means LCM of the numerator by HCF of the denominator. This all we learn in this chapter, and this chapter is very important. See, all fundamental basics, this we cannot avoid. Suppose somewhere we will use unknowingly also we will use in some chapters. So this all the things once everybody you write it in one notes once again, okay, and make it observe one time. If any doubt is there, once again you can ask for me. Okay, thank you.